Hello, welcome to another episode of Java Programming. This is Owen Riley, and today we are looking more at the collection interface. We've been looking at different types of collections so far in our first two installments here. We looked at an array list earlier as one of our examples. We've also looked at hash sets, hash maps, and stacks as part of our, and hash set, oh, I already mentioned that, hash sets as part of our um, generic collections. Today we're going to once again be looking at the array list. Notice that the array list will implement the list interface, and the list interface extends the collection interface. So we can instantiate a new array list because that will implement these abstract classes as those interfaces. So we're going to work with another array list today. So as part of that, what we want to do is what we're trying to do in this example is we have a list of street addresses, precincts, zip codes, and names that we want sorted so that we can display and work with our list. So what we're going to do, since we have more involved data type, we need a well-formed class. In our earlier examples, we worked with simple strings or simple integers, and now we're going to work with a class you might define. And in this case, this is going to be the list example class. This will be our well-formed class. It has two integers, a street number and a precinct, and then it has two strings, a zip code and a city. And we're going to not spend too much time on this. You've seen well-formed classes before, and hopefully you can write them yourselves without too much difficulty. We have a default constructor where we call our mutators. We have a full argument constructor where we send all this information and create our list, our object here, and calling our mutators again. Again, we call our mutators because that's where we want our edits to be if we have any. These are our accessors. Simply return our data. You've seen this all before, so I don't want to waste your time, talking about each one of these again. Here's our mutators. Now I did put one edit in here so you can see the edit in action in the mutator, and this is on zip code. Since zip code is a string, one of the things we learned about strings in an earlier section was that they can find out how long they are. So we want to make sure our zip code has to be at least a legal 5-digit zip code. Of course, we know it could be up to a 9-digit zip code now, but we're not worried about that. Although we could check that other end as well, but we're not going to. We're just going to use this simple edit, making sure our zip code is greater than 5 and returning that if it is. If it's not, we will not set our zip code actually. We'll just leave it no. Our toString then sends back our data in a usable format, as we'll see in just a second. So this is our well-formed class. To use these comparators, we're going to sort a class, so an object of a class. So you need to make sure you create one of these. For this week's lab, you'll need some type of well-formed class based on the properties of the lab that you'll manipulate. So let's see what our driver is now going to do as a client of this list example class. We're going to first of all create our list, which will be an array list. This array list, instead of holding a simple type, will hold our abstract data type list example class. So our list will be of type, in effect, list example class. Now, notice we can set up our code in this fashion, but we can also do this. I'm going to leave you two examples of this because you'll see it both ways. You'll also see this written with the word just list here. And that works just as fine because the list, the interface, lets us know that list example is going to fit inside that list, and we're going to further redefine it or define it, I should say, as an array list holding a list example class. So that way would work as well, and you'll see it both ways, and they do exactly the same thing. One way that will not work is if you try this. Let me show you one more thing here. This line we're not going to leave in, but I just want to show you that this will not work. If we try to make an array list, and over here we just put the word list, we're going to, if we put the word list, we're going to get an error because list, remember, is an interface. It's an abstract class, and you can't instantiate abstract classes. And that's what this says. Type mismatch cannot convert from that list to an array list. So you might try to fix that first, but the real error is the second one. I can't keep that cursor up there. The second one is cannot instantiate the type list example class. So in other words, even if I try to make these, get rid of that first error by saying list, I'm still going to get an error on this second one. Notice the error still says cannot instantiate that type. So this is illegal. This one won't work because you can't instantiate an abstract class. Keep that in mind. We'll leave it looking like this today. We do need one of them, so we'll list that. Here's how we'll build our list. Our street numbers 46231, our precincts 94979. So notice we have some duplicate precincts, all unique streets. We have zip codes that are some duplicates, and we have cities that carrying some duplicates. The first thing we want to do is see what our list looks like. We're going to print that out. Since an array list, remember, is just kind of a supercharged list, if you will, we can use the enhanced for loop, as we've seen earlier, by giving this list as input to our enhanced for loop, letting the enhanced for loop know what type of class this is. My tongue is getting twisted. I'm getting so excited. And inside this loop, we're going to call that object A. So we're going to print out then a.getStreetNumber, a.precinct, a.getZipCode, a.getCity. We could have pretty much had the same effect by printing out the toString as well, but we just want to show you this fashion. Why not, huh? So let's run that now. It has run. Let's see the output. I got to scroll up because I got a lot of code here that we haven't looked at yet. This is my unsorted list, just the way we put it in. 4964293719, and as you see up on the screen, that is the order we put them in. But we many times want to sort our list, and in this case we want to sort first on precinct number, this number right here, which we'll notice will have some duplicates. So to do that, we are able to, hold on, let me get to it. That's the print statement. There we go. We can call from the collections class, it has a method known as sort. Now this is all done automatically. When you call a collections sort method, if you give it a list, which is of type ArrayList, and you give it a comparator to use, in other words, how you want to compare this list against one another, then it will automatically sort them for you, and after it does that, we'll simply print out a sorted list again. And then we'll worry about those other ones in a second. Don't see that. There you go. So we're going to print the unsorted list. Then we're going to sort on precinct comparator. And then we'll print out our sorted list. Again, the syntax here is you use the collections class, call it sort method, give it an array list to use, and tell it how to sort. And this, notice we're creating a new list example comparator. So this is a class. This is calling the default constructor in that class. We have to write this ourselves for it to exist. So let's look at that. I've got one written right here. And in this comparator, we are going to first of all import java.util.comparator. And then in our class heading here, we'll give it our name, of course, and tell it that this is going to implement the comparator idea here from this utility package. Get away from me. And we're going to send it a list example class. Notice how this thing has to stay consistent as you pass things through here. And then if you have a class such as ours that implements comparator, if you program a compare method, this gets called automatically as part of this class. When we instantiated the new one in our driver, then it knows, since it's implementing comparator, it's going to call compare. And it not only will call compare, but it will call compare as many times as it needs to get your list sorted. So it will call it a certain number of times on a 5-item list, fewer times on a 3-item list, more times on a 1,500-item list. We're not going to worry about that yet, but we're just going to show the results, and then we're going to add this debug line. Pretend you haven't seen this line yet. But this is how we compare. It's a simple arithmetic statement. We take our precinct and we subtract from it our other precinct. Notice in our compare method, we said we're going to send you 2 list example classes, one called precinct A, one called precinct B. The beauty of this stuff is you don't ever have to call this yourself. It's called automatically by the sort method. You don't really send it these things. The sort method does automatically. Let's see what this looks like. Oh, and what it does is it gives you an integer result, and then it prints out, then it, in this case, simply returns that. We'll print it out in a second. So let me run this again. Actually, I didn't need to because it was already there, but that's okay. Here is our, I'll have to keep that in mind. Here is our unsorted list, 4964293719. Our sorted list now, notice we are sorted by precinct, 4, 7, and then 3 9s down here. But notice in the 9th precinct, which goes over 2 cities for whatever reason, it's not sorted by street. And many times you'd want to sort this by street. You'll notice that that is in the same order that our list was originally created in. In other words, we added the 4 before the 2 before the 1. If you go back to your driver, you can see that the first we added the 4, then the 2, and then the 1. Well, sometimes then we want to add an extra sort here. So to do that, we'll go to our precinct comparator. Well, before we do that, let's see what precinct comparator is sending us back. Excuse me. Through each iteration for this 5-item list by activating our print line. And now when I activate my print line, there's the unsorted list. And now this is what gets printed out each time. -5, and then 5, and then 0, and then -2, and then 3, and then 0, and then 0. Well, the way these are generated, if these subtraction problem ends up to be 0, that's what's returned. If precinct A is less than precinct B, it will return a negative number. And if precinct A is greater than precinct B, it will return a positive number. And the sort method behind the scenes handles all the heavy lifting for us, and that gives us this sorted list. But now let's say the workers come in and say, hey, I need this not only sorted by precinct, I need it sorted by street. Well, we'll come back to our comparator and we'll refine this a little bit. Let's just delete this line now that we've seen what happens. I'll tell you what I'm going to do. I'm going to comment that line out and then just move it, because it's just a debug line and I don't want it really getting in our way visually. We'll just paste it down there and you can use it later if you want to. So we'll do this. We'll get our compare, and if these two return a non-negative number, in other words, that 0, if they return a negative or a positive number, then we know we have unique precincts and we can go on. We don't need to sort any further. So we'll check this when it comes back. We want to find out if this precinct compare is not equal, if you will, to if the two precincts are not returning a 0. Remember, if these are equal, it's going to return a 0 here, or create a 0, calculate a 0. So we'll add an if statement. We'll say if, and we'll say precinct compare, copy and paste, saves me problems with typos, not equal to, and we'll say if it's not equal to 0, remember that means they're different. If it's not equal to 0, that means they're different. We'll just add that note. Precincts are different. Then we'll return the precinct. Now when you do that, notice now Eclipse has given us an error because our return statement is locked up. It says the method must return a type int, and it might not the way we have it set up here. So what we want to do then is another compare. What we can do is another compare, and let's say we want to compare then secondly, if the precincts are different, okay, we're sorted. And that's the condition we're kind of in now. In other words, if I would, well, I can't run this code because I have an error. So what I have to do, if I'm not going to return there, I've got to do another compare statement. So this time I'll set up an integer and I'll call it street compare. And I'll cheat because I'll copy this. Copy, paste, and then modify. And we know that we should have a get street method. If our well-formed class is well-formed, we know what it's named. I hope didn't I well-form it? What's going on here? Get street number. Oh, okay, my mistake. Get street number, I called it. I hope I did anyhow. And this is street number. But that's how these IDEs help you. They create information for you and let you quickly find where you might have typoed or something like that. There we go. So then we'll compare it on the street, and we're not going to care if they're the same. What we'll do in any case is we will now return street compare. If the streets are different, it will sort them. If they're not, well, it won't matter, and we'll demonstrate that as we go. And now notice our error has gone away. We have this new comparator here, precinct compare. is now going to sort by precinct and by street. We could have written a separate street comparator, but we don't really need to. We can do it all in one. And this is what we get. Here is our new sorted list. Notice now the streets are sorted 1, 2, 4. Precincts are all sorted 4, 7, 9. Notice since these precincts were different, we didn't care about street because our primary sort was on precinct. You can see how you could extend this. You could also then sort on city, which would be an interesting thing to try to do. Remember though, our other two items, if you try to sort on these are strings, and so you maybe sometimes need to, no, we're not checking for equality, we're just subtracting. No, you wouldn't have to do anything different. You'd be good to go. All right, let's continue to look at our driver. Now we want to look at some of these other things that our list can do. We've just sorted it and printed it out, and now another thing a collections can do is it can do a shuffle. A shuffle is a great item. Perhaps you had a list of 500 precincts and voters and things like that, and you wanted to shuffle your list and pick some at random. That would be a good thing to do for the shuffle. Say you had a card deck you needed to start a new game with. You could shuffle 52 cards in here. All you do with the shuffle routine is invoke the shuffle command, collections.shuffle, and send it an array list. Remember, these are array list things. And so when we run it again, then we will get our shuffled list. At random, if I run it again, my shuffled list will appear in a different order. Now what you got to understand is that when we actually shuffle, we actually change our list. When we sort it, our list gets changed. So when another thing a list can do, now again, to test these out, after the command, I just have simply copied and pasted my enhanced for loop each time and never changes. It always stays the same. Another thing we can do after we shuffle it, and there's the result of our shuffle, is we can reverse the list. And then once again, we'll print that list back out, just as before. And when we reverse our list, like I said, remember the list is actually physically changed here. So now notice I want to get both our shuffled list and our reverse shuffled list on the same screen. Notice this is the results of our shuffled list. What was reversed was not our original list. It's gone now. What's now reversed is the list after we had shuffled it. So remember, these commands actually change the list themselves. Change the list themselves. So you can't go back. You can't go back unless you back up your list. You can't go home again unless you back it up. Okay, so I think we're just about done here. A couple more things to show you. The iterator idea. Now we've been stepping through these using the enhanced for loop, and that's great. But sometimes you're asked to use a list iterator. So we'll step through our list using an iterator like this. First of all, let's cover that up for just a second and focus up here. First of all, we have to create a new list iterator, and look what we have to tell it which type it's going to be. Our list iterator has to be able to iterate through list example classes. And our iterator in this program will be called listit. And what it will do is it will go to our original or our current list, whatever state of our current list is, and use its method list iterator to make our listit able to iterate through a list. It kind of sounds like you're going in circles, and in a little way you are, but it works. Now we can have this all on one line like we've seen many times before, or we can have this on two lines, which sometimes you'd want to do, and sometimes you'll see it like this due to scope issues. We're going to use this way because we don't have any scope issues in this example, but I wanted you to see this because many times you'll see it listed in two lines instead of just one. Know that these two lines do the same thing as this line here. So that's why we're showing the one line method, but you'll see it that way, so be able to recognize it. So to iterate it, once the iterator is created, and remember our iterator is called listit, what we'll do is we'll say while listit still has stuff in it, while listit has next. We'll simply, for our purposes, print out what we found. We'll print the next one. We asked if it had one. If it does, we'll print it. And we'll just hold on for this one for just a second. We'll comment that line out for just a second so we can see what that's going to tell us in just a bit. So let's see then what we'll do. Let's leave this one out as well for just a second. And now let's run it. So what we're going to do again is just iterate through it with just a simple print command here. Let's do that. There we go. We'll see our output here. Let me scroll up a little bit. Our elements in the forward direction are, did I go up? Oh, I haven't gone up far enough. I apologize. I got to go higher. There we go. This was our reverse shuffled list. Now this is our list using iterator. Let me give us a little more in the output window. Elements in a forward direction. This is our list. Now notice in our iterator here, what we did in our while loop, if I can get down there, my machine is having a little bit of problems, is what we're telling it to print is the next record. And notice what the next record is really calling is it's printing our toString method. You might recognize that. This is really our toString method is what this line here is printing. And that's what we see on those results. And this is printing again our reversed shuffled list. Now, if we activate this line here, we can see how this works. This is going to be the previous index. Now the previous, let's run this again. Now in here we'll see an additional line of output. And in our previous index, going up there, we'll see this now. Our first item is now our previous item because we got it. We got it out of that stack. So our previous index was 0, and that's actually our first record. So that's why we see these are always the index of the record you just read when you get that previous index. The toString, I don't know if we'll demonstrate that. You can activate that on your own. What that will do is just show you the hash table address of this, hash table value of this item. So if you're entering this program, you can enter that line and activate it and see that hexadecimal address. Now, to print the items, iterate through our items in a backwards way, and this is our last item here today, is we will ask while it has a previous. And notice we just use the previous index up here, so this is the idea. So when we got these, we didn't change the list. The list still exists. We can go back and get them again. It's not like you pop things off a stack and can't retrieve them. On a stack, once you pop them off the stack, they're off the stack and gone. On a list, we can get them, but they're still there even after we get them. So we can say, well, as long as you have a previous, then what we want you to do is print listed.previous, and that's how we get our list here in a reverse order, which we'll see elements in a backwards direction. Notice this was our last one when we went forward. This is now the first one when we go backwards, because this is the back of the list and it's going up the tree, so to speak. So this was 6 and then 4, now it's 4 and then 6 and then 3 and then 2, and that's it. So I hope this discussion of the comparator and some of the other items that an example of this collections class will do for you. You never can tell when you need some of these methods, so I hope you enjoyed it. I hope this helps you out, and this is Owen Riley saying that's all for today. We'll see you next time.